sac324 number 2. We've got a milling machine. It's using energy, and the total amount of energy used up at any given time t is given by this expression, and we're asked to find the power. The power is the rate at which energy is being used up. So it's the time rate of change of the total amount of energy that's been used up at any given instant in time, which is just going to be the derivative of E with respect to time. We've got a constant out front, so the derivative of a constant times something is the constant times the derivative of that something. So I just copy the constant. And then we want times the derivative of the inside. The derivative of a constant, the 1 there with respect to time, is 0. And so we need the derivative of this piece. We'll have the minus sign. Then the derivative of the exponential function is just the exponential function itself. We're using the chain rule for the function of a function. We've taken the derivative of the exponent with respect to its argument. Now we have to multiply that by the derivative of the argument with respect to time, which will be all we have is a constant multiplying t, namely minus 1 over 9.25 seconds times the t, and the derivative of t with respect to t is just 1. Choose not to write that. 1 times anything is just the anything, or the something. And let's see, I copied down this constant incorrectly. It's 5,490 as opposed to what I wrote down. And this is P of t. Power as a function of time is given by this expression. Let's go ahead and simplify it just a little bit. Multiply, I got a minus times a minus gives me a plus, and then the 1 over 9.25 seconds can be multiplied by the 5,490 joules. I get for power as a function of time 593.5, and that'll be joules per second, which is a watt. So 593.5 watts times e to the minus t over 9.25 seconds. So the rate at which energy is being used up changes with time. In fact, it decreases with time. Probably the more material the milling machine moves away, the easier it is for it to turn, and hence the rate at which energy is being used up decreases. We're asked for the value of the power at a particular time. It was 18 seconds. There it is, 18 seconds after first contact. So we'll evaluate that expression for the power as a function of time at 18 seconds. E to the minus, and here's where I put in the 18.0 seconds for the time. And so P at 18.0 seconds is, rounding it off to 3 significant digits, 84.8 watts. This resulted from rounding 84.7826 watts down to 3 sig figs. So we get as our final answer